Welcome to Linux Shell Commands tutorial part 3. This is the final part of this basic Linux Shell Commands tutorial. In part 3 of this tutorial, I will discuss pipe and redirection features in Linux Shell. These two features are very useful and extensively used by shell programmers. But before we discuss these two features, you will need a bit of background as to what happens every time a command or program is executed at command line of a terminal. So when a command or a program is executed, Linux by default provides input and output connections or channels between the program and its environment. In other words, it provides connection from the program to the keyboard and to the screen, and it does it by default, Linux. So the three input and output channels or connections that Linux automatically provides are std in, as you can see here, std out, and std err. As you can see, keyboard is connected to std in, and the output coming out of this command would flow through std out into the device that is connected to std out, which is display in this case. Similarly, if there is any error generated by this Linux command, that error would flow through std err connection into the display. So by default, std in is connected to a keyboard, std out and std err, both of these are connected to the display of the terminal. Okay, but it is possible to connect std in to a file instead of a keyboard, and std out to a file also instead of a terminal, and similarly std err can be connected to a file as well, as shown in the next diagram here. It's possible to have an input file which provides input into the program instead of the input coming from the keyboard, and it's possible to send the output from the command into an output file instead of to the display, and any errors generated could be sent to another file called error file, or it could even be sent to the same file. But the idea is you can connect files to these three streams: std in, std out, and std err connections, right? Connections or streams. These are actually called standard streams: std in, std out, and std err. Okay, one other thing that we need to mention is Linux assigns file descriptors, which happen to be just a unique number for any file opened by a program. So it treats std in, std out, and std error as files. So it assigns the file descriptors or a number. As I mentioned, file descriptor is nothing but a unique number. So it assigns file descriptors to std in, std out, and std err. std in gets the number 0 as the file descriptor, and out gets 1, and 2 is assigned to std err. And this knowledge would be useful when we use redirection command. Now that we have the required background, let us first discuss redirection. And to do that, let's display the contents of slash user slash bin directory. So ls minus l slash user usr actually slash bin and press enter. As you can see, this directory has a lot of files. So uh, let's say that we want to save the output of this ls minus l slash user slash bin command into a file. We can do that by using redirection. And it is accomplished as follows. ls minus l slash user slash bin greater than symbol and the file name. Let us say we give the file name as listing.txt. So what is accomplishing redirection is this greater than sign that I highlighted here. That's what sends the output from this ls minus l command to this file instead of sending it to the display or screen. When we entered or executed this command, instead of sending the output to the display or screen, the output is now sent to this listing.txt file because we used this redirection here, right? That redirection symbol, you see. So let's see if that file got created. ls minus l listing.txt. As you can see, that file got created indeed. And let us look at the contents of that file, listing.txt. And you can see it has the output from ls minus l command that got stored into this file. So redirection is useful for saving the output that is going from the command into a screen, into a file, right? You can save the output into a file from any command that normally sends the output into a display or screen. Anything that sends the output into std out can be redirected into a file, right? So that's a useful capability to have. And one thing to remember is when we do this ls minus l slash user slash bin greater than listing.txt, it every time overwrites the existing file. For example, instead of ls minus l slash user slash bin, let's say we will copy whatever is there in the home directory. We're listing whatever is there in the home directory by giving this tilde sign, ls minus l tilde, which means it's going to list our home directory. But since we have this greater than symbol here, instead of listing that to the screen, it will save that output into listing.txt. And listing.txt currently has the output from ls minus l slash user slash bin command. And now by executing this command that I just entered, we overwrote whatever was previously there in this listing.txt. So if we now cat listing.txt, you will only see the output from the current home directory, right? See, this is the contents of slash home slash John that got listed here. So we have to be careful when we use this redirection command because it always overwrites whatever is there. If the file is existing, it will overwrite. If the file doesn't exist, it will create. Right? But what if you want to not overwrite, but add or append to what is already existing, right? See, currently we have this existing contents in this listing.txt file. Let's say we want to also add user bin ls minus output of the ls minus l slash usr slash bin command into this listing.txt. All that you need to do is specify two greater than signs, one following the other immediately without any space, right? Greater than, greater than. If you do that, it will not overwrite whatever is existing in this file. Instead, it will add or append to the existing contents of that file. So now if we execute this, if you see the top portion of this file, head listing.txt, it would still show this output that you are seeing here, right? Heading should still show this output, right? Head of listing. .txt. If you remember, head shows the first 10 lines of a file. So see, it still shows that output. And if you see the last 10 lines of this file, you will see that it indeed has output from slash user slash bin listing, right? So if you do tail listing dot txt, if you execute this command, you can see that. See the last, so the last 10 lines represent the output that came from ls minus l slash user slash bin, the output from here, right? So if you want to look at the entire file, you can do obviously get listing dot txt. It should show you the entire contents. And if you scroll back, you can see, I'm scrolling back to see at the top, we should see the contents of the file from my home directory. Oh my God, it's too big. So never mind. We will not do that. Anyway, you got the idea now. If you want to keep the contents and not override the contents, you need to use two greater than sign characters. And if you don't mind overwriting, then you can use just one character, one greater than sign. So if you use two, as you can see here, it will append. But if you use only one, as you can see here, it will overwrite or create if the file doesn't exist. If the file exists, it will overwrite. So that's the behavior. So that's for redirection. We saw in the previous examples how we can save the output from the execution of a shell command into a file. Now let's see if we can also save the errors generated from executing a shell command into a file. To do that, let us first generate an error from a shell command, and let's use cat command for that. Let's first check the contents of this directory, current directory that we are in, ls-l. We have all these files here, and let's try to do execute cat command on a non-existing file. This file xyz.txt does not exist here, right? You don't see it in this directory listing. So when we execute cat xyz.txt, you should see an error. And sure enough, it did show as an error. It tells us no such file or directory. And this error is displayed to the screen via the standard stream called stderr that we previously discussed. Errors are always sent using stderr connection, right? So if you want to capture this error also into a file, you can do that. So if you do xyz.txt greater than, let's say, error.txt, and we're expecting this error to be caught because it is getting sent to the screen. This will not work, but I just want to prove it won't work. So I'll execute this command. See, it is still showing it on the screen instead of sending that into err.txt, although we are using the redirection symbol here as highlighted, right? The reason for that is by default, when you use redirect symbol, it gets applied to std out, right? And the file descriptor for std out is 1. By default, it takes the file descriptor of 1 for applying this command, for this redirection symbol. But if you want to instruct the shell to send the output of the stderr into error.txt or into any file, you need to provide the file descriptor. 2 is the file descriptor for stderr, and give the file name, right? By doing this, we will be sending this error that you're seeing into this file, right? So let's do that. See, when we executed now, it did not show the error on the screen, which means the error got sent into this error.txt, right? You can actually check that, confirm that by doing this, right? See, the error got sent into err.txt, and the way to accomplish that is by specifying the file descriptor for standard error stderr just before the redirection symbol. And let's say you execute this command cat cities, actually let's say abc.txt. abc.txt does not exist either. All right, you don't see abc.txt anywhere here. Cat abc.txt and also cat cities.txt in the same command. Now, if you do that and just enter this, you can see that this part of the command actually generated an error, right? You can see that error, that's the first line. And the second part of the command, cities.txt, since it exists in this current directory, it actually got the contents of that file got displayed here, right? So both the error, std error and std out sent their content, they both the streams, they've sent their contents to the screen. That is why you're seeing this error line here, as well as the content here for the second file. For the first file generated an error, second file actually is existing, so the contents of that file are displayed here. Let's say you want to send this into a file, into an output file, and this into an error file, right? You can do that. The way to do that is greater than, let's say, output.txt to error.txt. If you do this, the error that got generated from this would go into err.txt because of this here, because of what we specified here. And the contents will get sent to this output.txt. We're instructing shell to send the contents of any output from std oet into this output.txt, and the output from stderr or any errors to be sent to err.txt. Okay, so if you now cat output.txt, you should only see this part. All right, you should only see this part. See, sure enough, we're only seeing that. And if you cat err.txt, you should only see the error that got generated because of abc.txt not being there, right, in this directory. So you can see that error got stored into err.txt, and output got stored into output.txt files. Let's discuss pipe feature next. Pipe allows you to connect output from one shell command to be fed into another shell command's input. So pipe feature allows chaining of shell commands. Let's see how that works. Let's just do ls-l here. No, you have these ones. Let's review one command called word count, wc command, because I want to use that command to show how pipe feature can be used. So I want to review wc command for the sake of people who are not familiar with that. So wc is a command that counts the number of lines, words, and characters in a given file. It takes a file name as an input, and it counts the number of lines, words, and characters in that file. So this file has 11 lines. cities.txt file has 11 lines, and it has 46 words and 382 characters. But if you want to only count the lines, you can do that by giving wc minus l flag. Minus l flag specifies to wc that it should only count the number of lines. We're only interested in understanding the number of lines in that file. So in this case, there are 11 lines, right? So keep that in mind. Now, let's look at ls minus l and slash usr slash bin directory again. As you can see, there are a lot of files in this directory. So now let's say you want to know how many files are there in this directory. You can use pipe for accomplishing that. So you will do ls minus l slash user slash bin. This will provide this listing. And what we do is we use pipe feature to send that output as an input into wc command. So this pipe character that you're seeing here is the character is what we use for specifying to shell that we would like to send the output from this first command as an input into this second command, which happens to be wc minus l. So if we do that, you can see that there are 1787 files in that directory, right? So remember, we need to use this pipe for doing that. Right? Pipe is that character that you can see under your backspace and above your enter keys on your keyboard, and you can access it by pressing shift and that key. It shares the same key as the backslash. So pipe symbol is what you use for piping output from one command into another command. You can chain any number of commands like this. For example, let's say I want to see all the files that are created in 2017 on the screen. Okay, so we can accomplish that by piping the output of this ls-l command into grep, and we would just specify 2017, right? So it'll show me all the files in this directory that are created or updated in the year 2017, right? So the output from this will be sent into grep as an input, grep command. Grep command then looks for this pattern and only displays the lines that match that pattern. So as you can see, these are all the files that are created in the year 2017 in this /user/bin directory. Let's say you want to count how many files there are that were created in 2017. You can then do another pipe and use wc-l command to count the number of 2017 files. There are 32 files. Also, you can use pipe and redirection together. For example, if you want to send the output that is getting shown here into your file, you can do this files 2017.txt. So the first command sends you the output. First command's output is piped into grep, and grep looks for 2017 and send this greater than symbol redirects that output from grep command into this file, files 2017.txt. So if you see, now there is a file called files27.txt created in my current directory. You can verify that, right? You can see that. And if you cat that file, you will see the contents of the grep command, right? That this what you're seeing here is what will be in this file, right? See, when you give the cat command, you can see that output. So we combined piping and redirection features, and we got the output that we wanted to get and saved that output into your file. So pipe and redirection features are really powerful and very useful and extensively used by experienced shell programmers. This concludes the three-part basic Linux shell commands tutorial. I hope it is useful for the beginners. If you find this tutorial useful, then please do subscribe to this channel. I will be adding content to this channel every week. Thanks for your time watching it.